Hello, curious souls and weary dreamers. I'm Dr. Weird, your midnight guide to places where sunlight never reaches. Tonight's voyage is the dark side of the moon. What secrets lie beyond the familiar face we see every night? Those shadowed craters, silent magma seas, and half-remembered echoes from forgotten missions. Settle into your pillow, let each inhale draw you closer to cosmic wonder. Each exhale, release the weight of the day. If you crave more sleep-time journeys through hidden worlds, tap subscribe and ring the bell so you never miss our next celestial lullaby. And in the comments, share where on Earth you're watching from and what time the moon rose in your sky tonight. Our community of stargazers spans every time zone. Now close your eyes, feel darkness deepen, and follow me into the moon's unlit hemisphere, where silence itself has a story to tell. If the moon could speak, would it reveal why it stays just far enough to rock our oceans, yet close enough to haunt our dreams? Take a slow, unhurried breath. Imagine a silent sphere, 238 by 5 miles overhead, reflecting sunlight that left the sun a full 1.3 seconds before it slips through your bedroom window. Slowly exhale and consider a single curious fact. The moon's off diameter, 259 miles, is almost exactly 1/4 that of Earth. Why not a third? Why not a fifth? What cosmic dice roll fixed the mathematics of our nightly companion? Inhale more deeply. Let your chest rise with the knowledge that the moon weighs 7.35 122 kilograms, only 1/80th Earth's mass. Yet its gravitational pull steadies our planet's spin. Without that delicate tug, strong enough to lift tides 50 feet in Canada's Bay of Fundy, would Earth wobble like an unbalanced top? Would seasons stumble, climates wander, life itself founder? Let the question linger in quiet darkness. Feel the mattress beneath you. On the moon, that same mattress would weigh a sixth of what it weighs here. Picture hopping across gray plains in slow motion, 6-foot leaps turning into 30-foot arcs. Each landing would raise a gentle puff of silvery dust, a fine powder. Billions of years old, why did an airless world grind rock into such soft talc? Could electrostatic lightning storms of dust still dance above the surface at lunar twilight? Now, shift your attention to time. One lunar orbit takes 27.3 days, yet a complete set of phases lasts 29.5 days. This odd mismatch, called the synodic month, occurs because Earth is moving too. So the moon must travel a little farther each cycle to bring its sunlit face back to full. Ask yourself how many ancient sky watchers puzzled over that extra 2 days, weaving myths to explain the delay. Hold your breath for a heartbeat. The moon's frontal face, riddled with dark basalt Maria, is only 28 miles thick on average. Flip it over in your imagination. The far side is a rugged highland crust, 60 miles thick and nearly Maria-free. Did a vanished impactor heat one hemisphere from beneath? Or was there once a smaller sister moon that flattened itself onto the backside, plastering mountains like frosting? Exhale slowly. Picture temperatures leaping from plus 260 degrees F at high noon to 280 degrees at darkest night. At such extremes, brass would melt, then snap like glass. Yet hidden inside eternally shadowed polar craters, ice lies undisturbed, perhaps 10 billion tons of it, kept colder than Pluto by walls that sunlight never reaches. Water on a world with no air. Will future explorers sip that frost? Or will it remain sealed by cosmic silence? With your next inhale, follow the faint smell of moon dust some Apollo astronauts swore they sensed, burnt gunpowder and wet ash. No atmosphere carries odor, yet their helmets trapped molecules freshly baked by ultraviolet glare and micrometeorite sparks. What stories would a single dust grain tell about its 8 billion-year journey from molten droplet to glass bead to the sole of Neil Armstrong's boot? Let your breath fall into rhythm. In 2, out 4. Each exhale is 2 milliseconds longer than it would have been a century ago, because the moon drifts away 1.5 inches every year, slowing Earth's rotation. If eons pass and days stretch to 25 hours, will future dreamers still call midnight the middle of night? Or will new tides write fresh music along faded shores? Now imagine the moon ringing. Apollo seismometers recorded moonquakes up to magnitude 4, some vibrating for nearly an hour as seismic waves ricochet through brittle crust. A hammer tap near an old lander sounded like a bronze bell dying slowly across 40 crisp minutes. What unknown hollows or lava tubes amplified those metallic echoes? Could an object lurk in those silent corridors, listening back? If numbers alone can rattle certainty, what unseen actors hide behind them, scripting lunar silence into cosmic suspense? Resume gentle breathing. Trace the path of helium-3 atoms blown by solar wind into lunar soil. Scarce on Earth, abundant out there. Enough perhaps to power fusion reactors for 10,000 years. What fjord of possibilities opens if humanity plugs its future into dust from an airless beacon? Who will own that silent fuel? Who will guard it, drift deeper? Every major crater you have ever glimpsed through a telescope holds a date. Copernicus, Tycho, Aristarchus, signatures of bullets traveling 25,000 in. With no wind or rain, those scars never fade. How many new impacts streak the far side this very hour, carving mile-wide bowls unseen by human eyes? Could a meteor strike tomorrow, reawaken buried magma, lighting the horizon with phantom fire? Count your pulse as you picture dust leaping in. Electrostatic fountains up to 60 miles high, as surveyor cameras once hinted, near lunar dawn. Invisible electric fields charge grains that fly, fall, and fly again, painting a fleeting glow along the horizon. Is that glow a cosmic promise or a quiet warning? And what delicate machinery might future travelers build out of the same restless static? If a single orbiting lantern can hold so many riddles in plain sight, what waits on its hidden face, the half forever turned away from earthly candles? Stay tucked beneath your blankets while the room dims. The moon is about to rotate in, your mind revealing the hemisphere no unprotected human eye has ever seen. Follow its silent spin into our next chapter. Eternal eclipse. What lurks on the moon's hidden hemisphere? Keep breathing slowly. Curiosity will guide you deeper into restful shadow. Eternal eclipse. What lurks on the moon's hidden hemisphere? Imagine a horizon you will never see from Earth, a realm where sunrise means nothing because the sun rises to greet no human eye. What hushed secrets drift in that endless night? Breathe in gently, letting the notion of perpetual darkness settle behind your eyelids. Though the moon takes 27.3 days to spin once and the same span to orbit Earth, tidal locking traps one face in a timeless stare, while the far side, often mislabeled dark, slips forever beyond our direct view. Exhale slowly and picture a landscape that has never hosted the blue glow of our planet in its sky, never mirrored northern lights, never felt the radio chatter of our civilizations. For millennia, that far hemisphere inspired speculation. Even Galileo confessed wonder as to what he could not glimpse. Today we possess crisp images, yet photographs cannot relay the startling relief of terrain. Towering scarps, spider-leg valleys, craters packed so tight they resemble a frozen sea of shattered mirrors. Why is this hidden face so battered while the near side lounges under wide dark Maria? Inhale curiosity, exhale doubt. Scientists trace the difference to crustal thickness, 60 miles beneath farside highlands versus barely 28 miles on the face. We know. Thicker crust shrugged off ancient magma, leaving no smooth basalt seas, only ragged highlands glittering with an orthosite, a pale rock that once floated atop a molten lunar ocean. But what cosmic architect stacked mass so unevenly? Did an impact stir molten layers? Or did a long-lost twin moon fuse into the far side, plastering mountains like frosting? Drift deeper. Soviet probe Luna 3 in 1959 first returned ghostly frames of that unknown half. Grainy silver halos revealed monstrous cavities, Hertzsprung, Tsiolkovsky, and the gargantuan South Pole Aitken Basin, a scar 1,550 miles wide and 8.1 miles deep. It may be the largest confirmed impact basin in the solar system. Imagine a collision so brutal that it cracked the crust, exposing lower mantle minerals to bitter space. Could clues to lunar interior composition wait there, sparkling in vacuum frost? Could ice hide in its permanently shadowed clefts? The oldest water in the inner system float across that basin now. Underfoot, regolith gleams almost chalk white. Under low sun, rims cast inky shafts of darkness that stretch miles. Temperatures plummet well below 250-degree rough each polar night. The vacuum is total. Your heartbeat would echo inside a suit while horizon glow flickers from electrostatic dust dancing along terminator edges. Each dust grain, electrically charged, may leap thousands of feet, tiny sprites skipping in star-filled dusk. Does that motion erase centuries of footprints? Or does it write silent messages, swirling glyphs only orbiters can read? Listen, orbiting. Spacecraft detect faint magnetized anomalies scattered across farside highlands. These local magnetic bubbles deflect solar wind, forming patches where radiation is gentler, surface brighter. Why do magnets litter a world without an iron core capable of generating a global dynamo? Some theorize metallic remnants of a colossal impactor melted into the crust, cooling into irregular lodestones. Others envision buried volcanic pipes suffused with iron titanium glass. Either scenario adds another layer to the hemisphere's enigma, pockets of invisible shields guarding patches of pale soil. What sleeping instruments of navigation or refuge might lie there for future explorers? Inhale calmly. Let the thought that nothing erases history on the moon fill you. Every crater on that remote face still holds micrometeor pits from last night's cosmic drizzle. You might kneel by a centimeter-wide divot made minutes before you arrived. Dust still warm from impact flash. If a probe recorded audio, would it capture faint pings of tiny stones slapping dust, like rain on sand? Some researchers propose placing ultra-quiet seismometers across farside plains to eavesdrop on constant micrometeor symphonies, and maybe on deeper murmurs, the slow groan of interior tides as Earth's gravity flexes the crust. Imagine falling, asleep to vibrations older than complex life. If the hidden hemisphere stores 1 billion years of unbroken memories, what tale will it whisper when the first human boot disturbs its silence? Settle even further. Geological maps show isolated deposits of orange-glow glass beads scattered near Amundsen crater, ejecta from past volcanic fire fountains that launched molten droplets high enough to vault the horizon and rain down hundreds of miles away. Their chemistry reveals traces of sulfur and zinc, elements that evaporate easily. How did such fragile volatiles survive vacuum for 3 billion years? Could sealed vesicles in glass still trap primordial gas, ready to exhale lost atmospheres with the prick of a drill? Above, the sky is pitch but alive. Without earthshine, stars blaze unblinking to the horizon, and the Milky Way arcs like powdered sugar. No ionosphere crackles, no aurora flickers, radio silence reigns. Astrophysicists dream of erecting low-frequency radio arrays in that hush to probe cosmic dawn, those first hydrogen whispers after the Big Bang. There, shielded from human transmitters, telescopes could tune to wavelengths impossible on Earth. Will we one night listen from crater rims and catch murmurs of primeval galaxies? Yet risks persist. Farside lacks direct line of sight to Earth, so explorers must rely on relay satellites orbiting L2. A single glitch could leave crews marooned behind stone, unable to call home. Could psychological loneliness echo louder than vacuum? Early Apollo. Planners feared just that. They rehearsed contingency orbits in case a command module's engine failed while skimming Farside. Radio blackout then meant 25 tension-laden minutes for controllers, ears pressed to static until the craft slipped back into light. One day a crew may spend weeks in that hush, their only companions heartbeat monitors and distant starlight. And if humanity plants a flag in that silence, will another flag already be there, faded, forgotten, laid in secret by hands we never met? Stay relaxed, inhaling through the nose, out through parted lips. Our next descent follows rumors that such secret hands once plotted a clandestine stronghold on lunar soil. Drift forward to Cold War ghosts, Soviet moonbase conspiracies revealed. Let curiosity guide you through the static. Cold War ghosts, Soviet moonbase, conspiracies revealed. Picture a scarlet flag quietly fluttering in lunar vacuum. No footprint trails, no radio calls, no press release. Did someone claim the far side first and simply never tell the world? Take a long, slow inhale. Feel the air slide past your teeth as though it were the icy wind of Baikonur on a winter dawn in 1959. The space race has not yet become public theater. Behind concrete walls, Soviet planners brood over blueprints labeled Zvezda, Star, a projected outpost of inflatable cylinders, airlocks, and nuclear heaters meant to nestle near the moon's south pole. Now exhale, releasing the frosty hush of a secret you have just overheard. The declassified fragments begin like puzzle pieces. One memo from Sergei Korolev's design bureau proposes 12 cosmonauts living in pressurized spider modules that could crawl across regolith. On telescoping legs, another file lists 3,000 kilograms of construction tools. Yet no launch manifest matches that cargo. Why plan for hammers and welders if no one intended to build? And why tuck the outpost on the hemisphere, forever hidden from American telescopes? Let your breathing find a quiet rhythm. In 4, out 6. Imagine the cover story. Officially, the Luna probes were mere robotic scouts. Luna 2 smashing into Mare Imbrium 1959. Luna 3 snapping blurry far-side images mere weeks later. But some engineers, decades afterward, admitted Luna 3's camera package weighed twice the mass needed for its resolution. What else rode that payload bay? A coded navigation beacon? A seismometer pre-drilled to broadcast Soviet telemetry from the far side? The documents stop short, pages torn, signatures redacted. Every blank line invites another question. Feel your spine melt deeper into the mattress. Outside your window, Earth's own tides still answer a lunar tug. Inside this story, tides of rivalry lift risky schemes. While NASA publicized Saturn V tests, the N-1 rocket rose on the Kazakh steppe under midnight curfew. 4 times it thundered skyward. 4 times it ruptured in flame before clearing the tower's shadow. Each failure smothered further talk of Zvezda, yet rumors persisted. A 5th, unnumbered launch, maybe February 21st, 1976, crew capsule unpainted to evade satellites, telemetry relayed through a listening trawler south of Madagascar. Official logs leave a gap of 13 hours that day. Engineers at Mission Control in Moscow recall a sudden order to stand by medical staff, then total radio silence, then a party directive to erase voice tapes. Does the gap hide a catastrophic attempt or an insertion burn that succeeded and simply never returned? Breathe evenly. Let the shape of a secret settle on the far horizon of your thoughts. Skeptics note the Soviets never perfected the LK lander life support cycle, yet blueprints depict an after-landing scenario. crewman exits. Hatch drives a Lunokhod 3 rover loaded with radar panels, establishes a repeater mast. Why draft such detail for an untried craft? Why produce 12 ceremonial red pennants made of titanium foil lighter than silk, immune to micrometeors, if none would be planted? In the early 1960s, Italian radio hobbyists, the Giudica Cordiglia brothers, claimed to intercept panicked Russian voices fading behind the moon. Their reel-to-reel tapes quaver with static. A woman repeating, "Goryu, Goryu, I'm burning." Western analysts remain divided. An elaborate hoax or a fragment of a training sim beamed from orbit. But one intelligence report, declassified 1992, concedes the signal's Doppler profile matches Ian's. Object receding from Earth at 8,000 diameters. Line of sight obstructed between 175 degree and 228 degree east longitude, precisely the far side arc. How easily radio ghosts masquerade as victims, or vice versa. If a transmission was swallowed by lunar rock, does it still echo there, bouncing forever between crater walls, waiting for the next receiver to tune the right silence? Allow that question to drift like a cosmonaut, untethered in low gravity, then breathe out. During Apollo 15, NASA's VHF circuits registered faint pulses while the command module lost line of sight. Engineers chalked them up to ionospheric crosstalk, yet frequency historians observe near-perfect alignment with Soviet shortwave distress bands. Could an automated beacon, decades old, still be pinging from beneath a dust-buried antenna? Lunar night radiates little noise. Batteries die, but isotope heaters linger. The half-life of a secret is measured in warmth, pushed deeper into calm. In 1994, the American Clementine Orbiter mapped surface iron, one hotspot, a mile-wide anomaly near Malapert Crater, registers iron-nickel alloy far richer than surroundings. Composition akin to stainless steel, not basalt. Impact slag or leftover hardware? Subsequent imagery reveals no fresh bowl. Shadows hint at a shallow mound, like buried struts under centuries of micrometeor rain. NASA lists it blandly, Mascon 91D anomaly. Conspiracy forums rename it Cosmo Shadow. Which label feels truer? Let your breath decide. Slow in, slower out. Between 1960 and 1974, Soviet film studios produced Sekretny Uchebny film reels, training footage for lunar dust storms, emergency drills, rover repairs. Stills show an interior set painted ash gray, with Cyrillic signs reading Sector 5, Montage Kislorodnovo Kupola. Analysts once assumed these were concept demos, but the last reel reveals an exterior shot. Pressure, suit silhouetted against what appears to be real, not stage, regolith, grain granularity, and lighting match actual Apollo photography. No internal lights, no ceiling rig. Could it be a test quarry under high sun, or a fragment smuggled from lunar footage, edited into instruction film? The negative's chain of custody has vanished under layers of archive reorganizations, calmly. Trace the thought of Soviet architecture rusting in vacuum. Aluminum joints grow brittle in proton bombardment, rubber seals crack. If Zvezda modules did land, today they would stand silent. Walls bleached by ultraviolet, windows fogged with micrometeor pits. Would a future rover find their outlines beneath regolith dunes? Perhaps only the titanium pennant rods remain upright, casting needle-thin shadows that creep millimeters each lunar hour. Imagine stumbling upon such relics by the light of a low. No flag, just poles like memorial markers pointing nowhere. Would you radio home or keep the ghost to yourself? Somewhere on that barren equator, a mystery may lie buried. Toes of a forgotten base, testimony to a gamble lost beneath gray dust. But every buried relic shares a deeper origin, a single cataclysmic impact that birthed the moon itself. Once, your eyelids rest heavy. Our next chapter rewinds 4.5 billion years to the roar that forged our haunted companion. Follow the silence backward to Impact of Doom, the collision that spawned our haunted moon. Keep breathing, each inhale, a countdown to cosmic dawn, each exhale a step deeper into restful dark. Impact of Doom, the collision that spawned our haunted moon. Close your eyes and imagine a newborn Earth, lava oceans glittering under a dim sun, when a rogue world the size of Mars tears across the sky. Can you feel the shockwave travel through time to the pillow beneath your head? Breathe in slowly. Let the air cool your lungs as though it were forged in a planetesimal shadow. 4.5 billion years ago, Earth was barely 30 million summers old, its crust a patchwork of floating plates, its atmosphere a choking haze of steam and carbon dioxide. Somewhere beyond Mars's orbit, a body we now call Theia, roughly 600 kilometers in diameter, had drifted into a resonant tug-of-war with the infant Earth. Each orbit nudged it closer, altering its path by mere hundreds of meters, until a single swing aligned their fates. Exhale softly. Imagine orbital mechanics as an invisible harp string plucked once, vibrating forever. When the inevitable came, impact speed reached nearly 10 km per second, 20 times faster than a rifle bullet. Theia struck at a grazing angle of 45 degrees, neither head-on nor glancing away, but perfect to gouge out a continent-sized scar and splash Earth's mantle into space. Shock waves rippled through the proto-ocean, magma fountains eclipsed the sun, debris equal to 2% of Earth's mass arced past escape velocity. Breathe in, feel that cosmic thunder rumble across your ribcage. Computer models rebuilt in supercomputing. Labs showed droplets of molten rock coalescing into a circumterrestrial debris disk. Within mere hours, an incandescent ring glowing hotter than any forge. Over weeks, the ring's inner edge fell back as metal rain. Its outer edge assembled into moonlets, the seeds of our single moon. Each new sphere melted itself anew, tidal forces shredding and rebuilding, until only one body dominated, mass 1C81 of Earth, orbiting at just 25,000 kilometers. So close it filled half the sky. Exhale. Picture tides 1,000 times higher than today, rock tides that made mountains rise and fall daily. But eyewitnesses, if microbial life already existed, would have seen more. Theia's core, rich in iron and nickel, likely merged with Earth's own, explaining our planet's anomalously large metallic heart. Meanwhile, lunar samples retrieved by Apollo missions contain identical oxygen-17 and oxygen-18 isotopic ratios to Earth's crust, the smoking gun that Moon and Earth share a single chemical womb. Why then does the Moon lack volatiles like water and potassium? Because debris vaporized, boiled, and recondensed in vacuum, leaving lighter elements to escape solar wind. Inhale the scent of scorched stone. No steam, no rust, just parched regolith. As you settle deeper, consider the aftermath. For 100 million years, Earth wore a fluorescent ring of orbiting shards. Each meteor storm rained down as late heavy bombardment, peppering newborn crust with craters whose ghostly basins we still map in Western Australia and South Africa. Did these meteorites carry amino acids baked inside Theia's mantle? Or did they sterilize early oceans, forcing life to restart? Paleobiologists debate, their arguments echoing like distant thunder in conference halls. Exhale, letting their uncertainty drift away like ash. Now direct your inward gaze at the moon itself. Tidal heating kept its magma ocean molten for up to 200 million years. Lighter plagioclase crystals floated upward, forming the bright anorthosite highlands you can see through a telescope tonight. Heavier basalt sank, later bursting forth as mare lava seas, mare imbrium, serenitatis, tranquillitatis. But these, Maria bloom only on the near side. Why not the far side? One theory posits that iron-rich debris from Earth blanketed only the hemisphere facing our planet, creating a radioactive blanket that reheated crust from below. Another idea: Theia's own iron core splashed asymmetrically, seeding heat-producing thorium and uranium along the near side. Either way, the impact's fingerprint still shapes every lunar sunrise. If one cosmic collision could script billions of years of tides, mountains, and eclipses, what hidden clauses remain unread in that ancient contract? Ease into slower breaths. Inhale for 4 counts, exhale for 6. Somewhere within the South Pole Aitken Basin, orbiters detect mantle minerals, olivine and orthopyroxene, thrust upward by the collision's seismic rebound. Could tapping those rocks reveal Theia's original chemistry? Engineers dream of drilling 2 kilometers down, sampling trapped pockets of primordial gas. Helium-3 there predates our Sun's second rotation around the Milky Way. Xenon isotopes might distinguish Earth mantle from alien mantle, answering whether Theia hailed from L5 or beyond Mars. Meanwhile, Earth's axial tilt, 23.5 degrees, may owe its precise angle to Theia's nudge. Without it, seasons would scarcely exist. Equatorial jungles could freeze, polar deserts might bloom. In cosmic what-ifs, humanity owes spring blossom and autumn harvest to that cataclysmic night sky flare. Let the gratitude soften your shoulders. Astronomers now monitor exoplanetary systems where moon-forming collisions still blaze. Infrared telescopes catch silica vapor signatures swirling around young stars. Celestial crime scene tape marking fresh impacts. Statistically, 1 in 10 rocky planets may host oversized moons, but ours is uniquely large relative to its parent. Such a stabilizer dampens climate chaos, perhaps turning improbable life into inevitable life. Exhale with the realization that our nightmares of destruction often turn mid-story into lullabies of stability. Yet the ghost of Theia remains restless. The moon drifts 3.8 centimeters farther each year. Long after oceans freeze, the rock tides will fade, Earth's rotation will lengthen to 47 hours, and lunar eclipses will vanish forever. Billions of nights hence, a distant descendant, if any survive, will look up and see a gray coin half its current size, wondering what cosmic dance once held it close. Inhale, hold that melancholy for a beat, release. Geologists have located at Earth's core mantle boundary 2 continent-sized blobs, ultra-low velocity zones, denser and hotter than their surroundings. New models propose these blobs are shards of Theia's mantle, buried 2 to 900 kilometers deep, still melting slowly after eons. If true, every volcanic arc from Hawaii to Iceland carries whispers of a long-lost world. Next time you warm your hands by a campfire, picture that flame's heat tracing its ancestry to a collision older than the oceans. If fragments of a vanished planet simmer beneath your feet, might hollow echoes still linger beneath the moon's crust, waiting for the brave to knock and listen? Stay nestled in darkness. With each breath, descend from planetary cataclysm into the subtler puzzle of empty-sounding tremors. Our next chapter peers into that echo chamber, hollows and whispers. Is the moon really hollow? Inhale curiosity. Exhale fear, and let speculation open cavernous doors beneath silver soil. Hollows and whispers. Is the moon really hollow? Close your eyes and imagine knocking on lunar stone. Would it sound like solid granite or echo like a cathedral of emptiness inside a silver shell? Take a patient breath in through your nose, counting 4 beats. Feel cool air slide past the tip of your tongue the way solar wind glides across gray regolith. Breathe out for 6 beats and picture Neil Armstrong's first boot print settling on dust older than coral reefs. When Apollo 12's seismometer registered their ascent stage crashing back to the surface, Mission Control noted something eerie. The moon vibrated nearly an hour, its seismic waves ricocheting inside so long that one engineer whispered, "It rings like a bell." Could stone truly sing unless hollows waited within? Let the question suspend in the hush between breaths. Seismologists later clarified that the bell-like ringing came from dry, fractured rock lacking the water that damps. Quakes on Earth. Still, the myth of a hollow moon sank its hooks into public lore. Inhale again. Review the data with curious calm. The moon's mean density, 3.34 g/cm², matches a ball of silicate rock, not a thin rind of metal around air. Its moment of inertia, factor 0.393, tells physicists mass concentrates toward the center rather than outward like a hollow shell. Yet Apollo quakes carried high-frequency harmonic overtones that labs on Earth rarely record. Why do vibrations bounce so cleanly through lunar mantle? Could giant lava tubes, 10 times wider than earthly counterparts, channel sound the way? Organ pipes carry notes? Exhale gently. In 2009, Japan's Kaguya orbiter beamed radar pulses into Mare Ingenii and discovered subsurface voids nearly 100 feet high and several miles long, vacant catacombs left by ancient lava rivers. A year later, NASA's Grail mission mapped gravity with precision down to a few microgals. It revealed hundreds of low-density corridors, some stretching under rugged highlands, others looping beneath volcanic domes near Muscovien's basin. These caverns aren't empty of rock. Their roofs arch intact, shielding yawning tunnels big enough to swallow Manhattan's skyline sideways. If astronauts walked into such a passage, helmets would fog with their own breath, while overhead hung 1 billion tons of basalt. Yet the void might feel as silent as an anechoic chamber. Now sip another breath and hold. Ancient myths add texture to science. In 1966, Soviet astrophysicists Vasin and Sherbakov published a speculative article claiming the moon could be an artificial planetoid, a titanium-reinforced shell capturing micrometeorites to hide its true age. Western tabloids spun it into the moon as a spaceship. Though mainstream researchers dismissed the idea, the notion found foothold in popular culture. Mysterious lights flicker across craters. Transient lunar phenomena wink on telescopic. Feeds radar echoes. Return anomalies shaped like polygonal cavities. Each story teases hearts that crave cosmic intrigue. Release your held breath slowly. Let tension slip away. Scientists confront the hollowness trope with numbers. If the moon were significantly empty inside, it could not raise tides, and its orbit would precess unpredictably. Yet minute anomalies remain. Farside gravity highs, maskins, tug low-flying probes, and certain Apollo tracks required mid-course corrections larger than models predicted. Could these fluctuations hint not at emptiness, but at honeycomb networks where once molten layers drained and froze? Some lava tubes may measure 30 miles across, their ceilings thick enough to shield colonists from radiation, micrometeors, and the cruel heat of lunar noon. Imagine stepping into such a cathedral. Freeze-dried stalactites of glassy basalt could hang like black chandeliers. Your boots would crunch on pumice fused 3 billion years ago. The only sound, your own respirator echoing down a corridor where no wind has ever blown. Inhale. Let that silence seep into your muscles. Exhale. Release every earthly noise. Halfway through Apollo 17, astronaut Jack Schmitt reported a brief orange glow near the horizon. Spectrometers later linked it to sodium atoms sputtering off rock, yet conspiracy writers proposed hidden exhaust from machinery buried below. Fantastical? Likely. But NASA still plans to drop micro-rovers into Mare Tranquillitatis Pit, a 328-foot deep skylight that may open onto a mile-scale cavern. One design unfurls a tethered probe with fiber optic umbilical sending 8K video from recesses darker than starlit midnight. What secrets will its floodlights awaken? Microbial spores preserved in obsidian glass? Lunar ice veins sealed from sunlight? Or merely emptiness so pristine it rewrites the definition of silence? If you whispered inside a 30-mile tunnel under 100 feet of basalt, would the moon keep your secret or echo it for eternity? Resmi tranquil breathing, 4 counts in, 6 counts out. Radar sounding of Aristarchus Plateau hints. At stacked voids, each layer a frozen snapshot of volcanic pulses. Italian astronomers analyze phase-shifted radar echoes. They see reflections at intervals, matching regular 50-meter spacing. Could magma once pulsed rhythmically, leaving symmetrical chambers like rib cages? Engineers dream of stringing superconducting power lines along those ribs, powering pressurized domes where lunar night never chills and micrometeor storms never strike. Meanwhile, geochemists chase isotopic breadcrumbs. Apollo core tubes drilled only 9 feet deep, yet captured glass beads with elevated argon-40, gas that diffuses from rock when heated. Some beads formed only 70 million years ago, implying volcanic burps long after the moon was thought geologically dead. Could deeper vents still exhale heat, feeding cavity networks? The Lunar Reconnaissance Orbiter's diviner instrument maps warmth seeping through crust cracks, subtle but persistent. Where heat flows, voids remain unclogged, hollows ventilated. Might a future traveler feel a faint updraft of ancient warmth while camping on the floor of a crater? Breathe slowly. Sense the borderline between fact and possibility. Popular culture revisits hollow myths whenever seismic data surface. Moonfall, Doctor Who, even 1901's The First Men in the Moon toy with lunar caverns housing civilizations. Yet the real hollows, lava tubes, may prove more alien than fiction. Sterile, pitch black, older than multicellular life on Earth, preserving cosmic ray tracks in glass the way tree rings store seasons. One day, scientists will harvest those tracks, decoding a timeline of supernova that sparked across the Milky Way while dinosaurs hatched. Exhale, loosening shoulders deeper into your mattress. Picture explorers installing acoustic sensors along tube walls, creating a lunar organ. Each meteoroid impact might vibrate pillars, producing data-rich chords that sing the moon's daily interactions with space. Even tiny moonquakes, thought to reach up to magnitude 4, could resonate through chambers, mapping unseen fingers through echo timing. Our hollow dreams might become seismology's finest tool. Now let your mind glide outward. If vast tubes exist, might some connect to sublunar voids formed in the impact's vapor plume, places where rock never recondensed? Gravitational models constrain cavity volume to less than 2% of lunar mass, but even that sliver equates to 1 billion Grand Canyons. Somewhere among them could lie pockets of helium-3 rich regolith, priceless fuel waiting in darkness. And where lava once flowed unseen, might liquid fire still hide. Dark magma seas, deeper than any crater, pulsing, warmth beneath a frozen shell. Let eyelids rest heavy, breaths slow and steady. We leave hollow passages and descend toward hotter mysteries, molten echoes trapped below basalt. Follow the simmering trail into our next chapter. Shadowed secrets that dark magma seas you can't see. Let each exhale melt like lava cooling under lunar night, guiding you toward deeper rest. Shadowed secrets, the dark magma seas you can't see. Beneath a crust that looks cold as ashes, the moon still keeps memories of fire, hidden seas of solidified magma that glow only in infrared dreams. Breathe in slowly, feeling warmth pool behind your ribs, the way molten rock once pooled beneath a younger moon. Exhale and picture a world 200 million years after the Theia collision. A globe wrapped in a global magma ocean. Its surface, a rolling scarlet tide of silicate melt. Lunar night never fell then. The entire sphere glimmered like a paper lantern in vacuum. As it radiated heat, lighter crystals of anorthosite floated upward, forming an ivory crust. Heavier iron-rich basalt sank, settling into a convecting interior still 1/600 degree C hot. Fast forward 100 million silent orbits. The near side's thinner crust cracked like ice on a pond. Basaltic floods gushed upward, painting Mare Imbrium, Oceanus Procellarum, Mare Serenitatis. Each flow may have lasted tens of thousands of years, draining subterranean reservoirs the way a wound drains blood. Yet on the far side, those reservoirs remained buried, strangled by crust up to 60 kilometers thick. Their heat had nowhere to escape. They cooled slowly, forming cryptomeria, dark seas locked beneath pale highlands, invisible except to penetrating radar. Inhale again. Let that trapped warmth settle under your collarbones, a secret you alone can feel. Modern orbiters map gravity so precisely they sense variations smaller than a sheet of paper's weight. NASA's Grail twins revealed subsurface dikes, vertical sheets of once liquid basalt, threading hundreds of miles under crater chains. Some dikes rise to within 2 kilometers of the surface before stalling, frozen in time like black lightning captured in stone. Why did these dikes never erupt? Perhaps the shallowing crust cooled them too quickly. Perhaps overlying rock was simply too strong to crack. Exhale softly, imagining pressure building, then falling silent for eternity. Yet silence is relative. The Diviner radiometer aboard Lunar Reconnaissance Orbiter photographs night-side surfaces glowing a few degrees warmer than surroundings. These hotspots cluster around thorium-rich soil, evidence of heat-producing elements, creep, potassium, rare earths, phosphorus, trapped between anorthosite roof and basalt floor. Scientists believe these creep pockets once fueled local volcanic episodes hundreds of millions of years after global cooling should have ended. Could embers still flicker? Seismic models hint at partial melt 50 kilometers down, only 1% liquid, but enough to lubricate moonquakes that ring like crystal goblets. Let your breathing fall into rhythm. In for 4, out for 6. Imagine walking at dusk along Aristarchus Plateau, the brightest volcanic province on the moon. Underfoot lies Cobra Head, a collapsed lava vent where pyroclastic beads the size of poppy seeds blanket slopes in burnt orange glass. Those beads formed when gas-charged magma fountained a mile high, quenching into spheres mid-air before raining in silence. Each bead captures vesicles of gas, sulfur, fluorine, carbon monoxide, chemical diaries of deep interior plumbing. Might future explorers crack them open, sniffing the petrified breath of an extinct volcano? Beneath Oceanus Procellarum, gravity maps outline a vast rectangular scar nicknamed the Procellarum Creep Terrain. Some planetary scientists propose it is the fossil imprint of a gargantuan plume head, hot, buoyant rock rising from the lunar mantle like a blister. When the plume stalled, its top pressed against the crust, thinning it, melting it, doping it with radioactive thorium. Over eons, this warm blanket kept near-side basins hotter than far-side highlands by up to 50 degrees C. Could these temperature contrasts explain why mare basalts make up 31% of near-side surface, but less than 1% of far-side? The moon is a tale of two hemispheres carved not just by impact but by hidden heat. What if the face we see is only a burn scar, while darker seas lie, buried, their tides frozen, their stories still simmering in shadows? Relax shoulders deeper into the pillow. Think of Cryptomare Schiller-Schickard. To the naked eye, a simple highland plain, yet orbital radar peers beneath regolith and discovers an oval sheet of basalt 40 miles across, capped by 5 yards of dust. Its radio echo time lags microseconds, longer than surrounding rock, a ghost fingerprint of lava unseen. How many other seas sleep under bright crust, waiting for ground-penetrating rovers to map them like doctors scan hidden tumors? Engineers sketch rovers with tethered drills cooled by liquid nitrogen, able to core 30 months down and return blue-black basalt so fresh it crumbles in sunlight. Breathing steady, examine the possibility of ongoing volcanism. In 2014, high-resolution cameras photographed a 3-kilometer pit in Lacus Felicitatis with blocky mounds and sharp-edged boulders free of micrometeor scarring. Crater count dating suggests surfaces younger than 100 million years. Some researchers argue Ina formed when a pocket of magma degassed recently, puffing up crust like bread, then collapsing. If volcanic burps occurred in the moon's recent past, could minor eruptions happen again? Perhaps not fountains, but slow extrusion of glassy domes, heat faint yet measurable during a long lunar night. Future astronauts might watch a horizon, glow not from dust, but from cooling obsidian. Would they feel fear or awe? Breathe out, letting wonder buffer uncertainty. Heat leaves other clues. Apollo seismic networks recorded deep moonquakes, clusters recurring monthly at 700-kilometer depth, triggered by Earth's tidal pull, flexing still warm mantle. Each tremor releases energy equivalent to magnitude 2 quakes on Earth, gentle but persistent. Over billions of cycles, they remind us the interior is not wholly solid. The lunar core itself, 85% liquid iron-nickel with a solid center gem, generates local magnetic pockets that imprint crust when lava cools. Every mare plane is thus a fossil compass pointing toward vanished fields. If you held a magnetometer above Imbrium basalt, the needle would twitch at remanent microtesla whispers centuries old. What stories hide in that flicker? Inhale deeply. Remember that lava tubes discovered in Marius Hills may extend 50 kilometers. Some sections likely host collapsed skylights, entrances into underworld rivers of frozen basalt. Inside, temperatures hover around 20 degrees Celsius, far warmer than surface night lows. Ice could sublimate from regolith and coat walls in fragile frost. Step. Inside mentally, helmet lamp off. Darkness is complete. A gentle exhale fogs visor. The sound rebounds off unseen walls, proving emptiness, bigger than any concert hall. You are literally inside a vein of the moon's prehistoric circulatory system. Envision mining robots lining tube floors with radio antennas, miles long, shielded from solar noise by 60 feet of rock, turning a dead volcano into the quietest observatory in the inner system. Cosmic dawn signals, the 21 centimeters whisper of first hydrogen, could be recorded here unpolluted by earthly chatter. Thus, the moon's extinct magma seas might birth humanity's keenest ears on the universe. If buried fire still hums beneath silent Maria, what echoes linger above, where relic spacecraft rest in darkness, their last radio size fading into endless night? Let your next breath glide deeper, carrying the warmth of ancient lava into quiet limbs. Our journey now turns from molten whispers to mechanical ghosts, tracing the final haunting radio silence of Apollo explorers. Drift forward into Apollo's last echo, uncovering death's silence on the dark side. Feel curiosity coil around calm as you slide towards sleep. Apollo's last echo, uncovering death's silence on the dark side. Picture yourself orbiting a moonlit coast that no sunlight ever fully warms, radio silent, Earth tucked behind stone. When every heartbeat thuds in your headset, how loudly does the universe feel? Inhale softly, counting to 4. Exhale to 6, and let your thoughts drift to December 14, 1972. The final night a human stood on lunar soil. Commander Gene Cernan and geologist Jack Schmidt prepared to leave Taurus Littrow, their boots dusted with silver grains. Mission planners called it the last great leap. The astronauts called it bittersweet. What none spoke aloud was a shared superstition that a silence older than the craters haunts anyone who lingers too long on the moon's far edge. Long before Apollo 17, test flight skirted that hush. Apollo 10 dipped to within 8 nautical miles of the surface, practice landing on nothing, engines rumbling in the vacuum like distant drums. As the craft glided into radio blackout behind the moon, astronauts Stafford, Young, and Cernan heard an eerie whooping in their headphones. Transcripts labeled it space music. Engineers later blamed VHF interference between 2 radios. But let your next breath entertain possibility. What if, in the absence of earthly signal, the void sings its own lullaby? Now, picture PFS-2, a suitcase-sized seismometer Cernan placed in dust minutes before boarding the ladder. Designed to run for a year, it transmitted temperature and quake data at 226 micronorichters. 3 weeks later, when the sun set over Taurus Littrow, temperatures plunged to 240 degrees. Telemetry should have fallen silent until sunrise, yet ground stations logged a single faint ping 46 hours into night, too weak for decoding, too strong for noise. Breathe in, hold, exhale, feeling that lone pulse ripple through the dark. Some technicians insisted it was a cosmic ray hit. Others archived it as unexplained anomaly, SH-47. Years earlier, Apollo 15's ALSEP system shut down abruptly. Battery depletion, the report read. Yet the primary battery still measured 26 volts. A backup circuit had tripped itself as though commanded. Did static discharge flick a relay? Or did lunar night charge dust enough to short exposed leads? No one knows. The lander stands there, still electronics mummified in frost, perhaps waiting for a solar proton storm to jolt a last whisper across void. Breathe slowly. Consider that every Apollo lander left behind a passive laser reflector, corner cube prisms that bounce light so precisely scientists can measure Earth-Moon distance within millimeters. Most reflectors shine true, but the Lunokhod 2 array, delivered by a Soviet rover in 1973, dimmed mysteriously after a year. Dust blamed again. Yet reflector brightness faded more during lunar night than day, opposite dust-settling models. Could electrostatic levitation at sundown blanket the rover in a veil of grains, muffling its glass eyes until solar photons shook the dust free? If so, might other instruments, now entombed, mumble through dust drifts, their signals attenuated like ghost voices behind curtains? Exhale, letting shoulders sink. Among the most haunting relics is subsatellite SB, an 80-pound sphere released by Apollo 16. It mapped magnetism for 5 weeks, then crashed unseen onto farside highlands. Impact coordinates remain uncertain. Somewhere beyond direct Earth contact lies the shattered orb, its tape recorders strewn like beads. If a rover rolled past, would its magnetometer twitch from residual coils? Would its radiation counters tick? Once more of sunlight warmed a transistor. When a machine's last breath fades in lunar night, does silence truly fall? Or does the moon keep whispering in frequencies we no longer tune? Let your breath flow in gentle waves. Imagine a future. Crew venturing to Malapert crater rim, erecting a low-frequency radio array. While aligning dipoles, they stumble on a tiny dust-soft mound. Brushing it reveals a gold foil wrapping, a piece of Apollo 17's lunar sounder experiment boom, sheared off during ascent and arced farside by orbit decay. Its antenna plates, still charged by solar wind, crackle faintly in headset speakers. At unplanned data point bridging half a century of gap from orbit modern craft listen to. NASA's Artemis probes, repurposed Themis satellites, detected Whistler waves above farside. V-shaped chirps triggered when Earth's magnetotail snaps across the moon. Some pulses align with old ALSEP beacon frequencies. Coincidence, perhaps? Yet each detection reminds mission teams that lunar hardware, though silent, interacts with plasma environment long after design life. Breathe in the idea of relics turning into unintentional sensors. Breathe out into deeper calm. Even human remains orbit within this tapestry. When Ron Evans left Command Module Casper to retrieve camera film, he lost a wrist mirror. That palm-sized shard still circles the moon, a tumbling spark glimpsed by amateur telescopes in 2011. Could such a trinket re-enter lunar gravity well one day, skitter across regolith, plant microscopic vibrations on a long-dead seismometer, delight in the chain of tiny causes, drifting like feathers across decades? Note the J02E3 mystery. In 2002, astronomers spotted a faint object looping Earth-Moon region every 47 days. Spectra-matched titanium paint used on SIVB stages. Orbital reconstructions fit Apollo 12's booster, flung into solar orbit in 1970, captured back by Earth 32 years later. It has since escaped again, set to return around 2040. Imagine the hush inside that hollow cylinder, instruments frozen. Mid-reading, temperature gauge fixed at -infinity, accelerometer needle hung forever. When it swings by next time, will ground radar read a new resonance, perhaps from micrometeoroid hollows hammered in thin walls? Exhale. Let drowsiness bloom as shadows lengthen. Between 1966 and 1968, 5 uncrewed Surveyor landers practiced. Soft touch touchdowns. Surveyor 3's TV camera kept transmitting snow until night-chilled circuits below survivable limits. Yet, when Apollo 12 astronauts visited 2 years later, they found traces of Streptococcus bacteria inside a foam sample, maybe contamination during decontamination, maybe proof life persisted 40 lunar nights. Either way, a hush inhabited that camera until footsteps woke it briefly, a reunion of ghosts across time. Now widen your field to radio astronomy. The far side offers the purest quiet in the inner solar system, shielded from Earth's chatter. Yet faint narrowband peaks at 1.2 MHz sometimes pop above noise. SETI analysts dismiss them as lightning on Jupiter, but timing often syncs with Earth-Moon libration, bringing abandoned S-band antennas into certain solar wind angles. Could reflections off metallic debris modulate plasma noise into symmetrical spikes? Each unexplained ping is logged, labeled S-burst anomaly, then archived, perhaps for a future scholar to connect with hardware we forgot. Breathe deeper, lengthening exhale to 8 beats. Think of silence not as absence, but as an ocean, filled with low-amplitude waves. Old transmitters, cracked capacitors, even corroded solar panels resonate in vacuum when thermal gradients flex them at dawn. Piezoelectric crystals and guidance gyros might hum ultrasonically as they cool. If you placed a geophone on lunar soil, beside an abandoned ascent stage, what lullaby would it hear at sunrise? Some echoes die slowly, others wait for ears attuned to whispering static. What phantom choir greeted Apollo 8 as it looped the moon and slipped beyond Earth's reach for the very first time? Keep breaths smooth. Let eyelids weigh heavy. Our next chapter rewinds to that pioneering orbit where 3 men heard unearthly music in radio silence. Drift forward to far-side phantoms, Apollo 8's haunted orbit. As curiosity guides you deeper, let calm envelop every limb like lunar night around forgotten machines. Far-side phantoms, Apollo 8's haunted orbit. 3 men drift behind the moon, Earth shrinks to nothing, radios fade to hiss, and a lonely spacecraft slips into the universe's quietest shadow. What if something waits in that hush? Inhale, slowly through your nose. Feel the breath cool and widen inside your chest, the way oxygen filled Apollo 8's cabin on 24 December 1968. Exhale softly, and picture Commander Frank Borman, Command Module Pilot Jim Lovell, and Lunar Module Pilot Bill Anders. peering through tiny windows, watching the bright limb of Earth slide below a cratered horizon. A single word crackled over the loop: loss of signal. With one syllable, Houston vanished. For the next 47 minutes, Apollo 8 glided in radio blackout, cocooned by lunar rock 900 miles thick. No telemetry, no heartbeat tones, only the soft hum of glycol pumps and the occasional click of a checklist page turning. What did the silence feel like? Lovell later wrote that it pressed on the ears like deep water. Take another breath. Imagine that pressure easing your pulse into lunar rhythm, steady, deliberate, patient. Halfway through the first backside orbit, unexpected sounds seeped into headsets, a high-pitched whoop-whoop repeating every few seconds, accompanied by a lower buzz that faded in and out. Anders laughed uneasily. That's some kind of space music. Borman quipped, I hope the aliens let us go home. Engineers later chalked it up to VHF interference between signal processors. Yet recordings replayed on Earth still feel uncanny, notes swirling where no radio should reach. Could plasma sheaths around antenna tips have mixed carrier waves into ghostly chorales? Or did lunar magnetic anomalies twist microwaves into a spectral chorus? Let the mystery float for a moment, suspended between breaths, outside, the far side. Revealed itself, a chaos of ancient craters 4 miles deep, peaks knife-edged and sunlit against ink-black sky. Unlike the near side's reassuring Maria, these highlands gleamed bone-white, untouched by seas of basalt. Looks like a sand pile my kids have played in for centuries, Lovell mused, voice hushed. The spacecraft skimmed 69 miles above the desolation, close enough that mountain shadows flickered across the hull panels. Picture that passing landscape as you inhale, jagged silhouettes sliding under belly plates still warm from engine burns. Exhale and feel cool darkness wash across your eyelids as if you too trace that orbit. During the fourth Farside Pass, the crew rehearsed a special broadcast. They would read from Genesis while Earthrise blossomed ahead. But until acquisition of signal, they practiced in the lonely dark, pages lit by instrument glow. Anders recited softly, voice soaking into cabin walls. Borman, battling a stomach virus, closed his eyes and pictured family carols 13 time zones away. Somewhere near cratered Tsiolkovsky, the service module heater cycled off and cabin temperature dipped 2 degrees, the only reminder that life support carried their winter. On the 6th loop, telemetry resumed just long enough to relay an odd spike. The guidance computer registered a roll rate of 0.4 degrees sec, though thrusters were idle. Mission control suggested inertial measurement. Drift. Lovell suspected a micrometeoroid kiss. After blackout, they searched hull windows. No pit marks. Could mass concentration anomalies tug attitude sensors? The same mascons that once yanked Ranger and Lunar Orbiter orbits downward. Apollo 8's path grazed over Mare Moscoviense, a mascon, region later mapped by Grail. Imagine gravity fingers invisible, stroking metal skins, coaxing small motions in perfect night. Breathe in the idea, breathe out the tiny shiver of unmeasured forces. NASA psychologists had warned of sensory deprivation behind the moon, no stars visible on sunlit interior, no radio chatter, only instrument glow and suit rustle. To offset monotony, the checklists were dense. Yet several times Anders paused, letting time elongate. He reported faint clanks, thermal expansion of panels, or was it? Microfractures popping in aluminum honeycomb, or echoes of their own heartbeats amplified by helmets? Settle deeper into pillow and imagine each faint tick reverberating like a knock from distant halls. Years later, digital cleanups revealed layered frequencies in the music. One tone matched the VHF ranging carrier, another fell near 2.4 kHz, a harmonic of the service module environmental fan. Yet a residual 1.6 kHz signal remained unexplained, drifting with cabin temperature. Sound engineers speculate nonlinear mixing in transceiver diodes. Some fringe theorists whisper of low-frequency lunar radio emissions. There is no proof, only an open question humming between data points. Let that question rock you gently, like static between distant stations on a night drive radio. If silence can sing and gravity can tug at pulse and mind, what else hides in the shadowed hours where no earthly ear can listen? As blackout ended each orbit, a sliver of Earthrise appeared, blue marble cresting gray limb. Telemetry surged. Console lights in Houston flickered to life. Controllers exhaled. But the astronauts felt something else, a pang of loss for the hush they were leaving. Borman later confessed the far side dark became a kind of cathedral, vast, austere, echoing with nothing but everything. Inhale now. Feel that hush expand inside your ribcage. Exhale. Let it settle like dust in a crater, undisturbed for eons. Apollo 8 proved the humans could survive extended blackouts, could trust onboard computers to ignite SPS engine, unseen by ground. It paved the way for Apollo 10's low pass, Apollo 11's landing. Yet those who followed listened for the phantom chorus and sometimes heard faint variations. Apollo 10 recorded chirps. Apollo 15 noted burbles at periapsis. Engineers filed anomalies, improved filters, moved on. But each transcript still carries margin notes, odd audio, possible interference, investigation deferred. The moon keeps its minor key unresolved. The moon's song lingers, yet the crust itself shudders with deeper rhythms, quakes that last for hours, shaking dust like frozen sandstorms. What stirs the stillness of a world long thought dead? Maintain your slow breathing. As cabin lights dim in your imagination, follow vibration rather than melody. Drift onward to silent shivers, the moon's unsettling lunar quakes. Let curiosity guide you through the tremors faint beginning into restful dark, and feel every exhale settle like regolith after a distant impact. Silent shivers, the moon's unsettling lunar quakes. In a world with no wind, no water, and no tectonic plates, can stone still tremble? And if so, what unseen fingers pluck those chords of silent shiver? Breathe in slowly and feel the sea mattress cradle you as though it were the pale powdery regolith of the sea of tranquility. Exhale for a count of 6, allowing tension to drift off like dust in the lunar dawn. The moon looks frozen, gray, cratered, silent, but hidden beneath. It's an orthosite crust, something stirs. Sensitive seismometers left by Apollo 12, 14, 15, and 16 recorded more than 12,000 distinct moonquakes during 8 years of operation. Some were gentle rumbles. Others rang the entire body like a bronze gong for nearly an hour. Tonight, we listen for those quakes, tracing their whispers through solid rock. Deep moonquakes occurring roughly 700 kilometers below the surface, these events pulse once every 27.3 days, as regularly as tides. Each cluster aligns with Earth-Moon gravitational tug. Our planet squeezes the moon's interior, just enough to make mantle rock fracture. Imagine the sound, a bass drum you cannot hear, ticking with lunar months, like a cosmic heartbeat, sustaining sleep. Shallow moonquakes, rarer yet haunting. Sensors registered magnitudes up to 5.5 on the moment scale, strong enough to rattle dishes on Earth. One such quake lasted 10 minutes near Apollo 17's landing site in 1972. What force shakes brittle crust so violently on a supposedly dead world? Some scientists blame thermal stresses at sunrise. Others suspect relic magma chambers still cooling, contracting, thermal quakes. Each dawn, the top meter of dust warms by 300 degrees. Dry grains expand, popping and clicking like campfire. Logs, microphones on modern probes might record faint crackles if we cared to listen. Breathe in that image, a billion grains stretching in morning light. Exhale, and hear the crackle dissolve into calm. Impact quakes. Meteoroids strike the surface at 25,000 mph every few hours. Without atmosphere to burn them, even marbles become bullets. The seismometers shivered as tiny stones peppered the soil, an endless gravel rain, carving silent punctuation into lunar time. When Apollo 12's ascent stage was purposely crashed, the P-wave sparked a resonance that persisted 55 minutes. Mission. Engineers described the signal's decay curve as almost undamped, unlike anything on Earth. Dry rock, sparse fractures, and a solid iron core together form a near-perfect resonator. Visualize yourself inside a vast crystal cavern where each footstep circles back, layering echoes until silence itself vibrates. Inhale, feel subtle hum beneath ribs. Exhale, release it into darkness. For decades, scientists assumed the moon's core was stone cold. Then, reanalysis of Apollo data suggested a small liquid outer core, secondary 40 kilometers radius, swirling around a solid inner core, almost 70 kilometers. That metallic swirl responds to Earth's gravity, stirring eddies that tug at mantle rock above. Each tidal swirl raises solid-state rock tides up to 40 centimeters. Not enough to notice with eyes, yet enough to flex faults and send tremors rippling outward. Picture granite bending like rubber, ever so slightly, once a month. Could fractures grown over billions of cycles eventually propagate to surface, opening fissures for escaping gas? Orbiters occasionally detect transient blooms of argon-40 venting from Aristarchus region. This isotope forms when potassium-40 decays in warm rock below 60 kilometers. A shallow moonquake might crack a conduit. Gas rushes upward, lofting dust in electrostatic plumes miles high. Perhaps some transient lunar phenomena seen by astronomers, brief. Flashes, mists, glows, or seismic burps illuminated by low sun. Inhale this possibility. Exhale, picturing a chalk-white plume drifting, then falling in slow motion, snow in vacuum. If the moon hums with tides of stone and breathes argon sighs, are we glimpsing the aftershocks of a birth trauma that never truly healed? Each deep moonquake cluster is tied to a single nuclear family of faults. Across half a century, those clusters remain at constant latitude-longitude depth. Scientists liken them to resonant nodes, predictable as full moons. Monitoring such nodes gives clues to the moon's viscosity and heat flow. ESA's upcoming Farside Seismic Network plans to drop whisper-quiet optical seismometers near crater Schrödinger. They will detect vibrations 1,000 times weaker than Apollo gear, mapping microcracks and potentially listening for subsurface lava tube collapses. Could future sleepers on the moon ride out quakes in those giant tubes, safe from radiation, yet vulnerable to caverns' slow-settling groans? Unlike deep quakes, shallow events strike unpredictably, some epicenters near mere highland boundaries. A 2019 Nature study used LRO imagery to spot fresh landslides correlating with seismic signatures. Boulders as big as school buses had rolled downslope in the last decade. Fault scarps tens of kilometers long look crisp, their edges unsoftened by micrometeor bombardment, evidence they formed less than 50 million years ago. The moon still shrinks as its core cools, crust wrinkles like dried fruit. Each wrinkle may jolt the surface in a magnitude 5 quake, enough to snap an aluminum habitat beam. Engineers now model base placement away from these thrust faults. Imagine yourself inside a pressurized module, near the South Pole, sun below horizon. Regolith outside sits at 230 degrees. Suddenly floor panels twitch, a deep moonquake arrives, nothing falls, but suit helmets resting on racks rattle. Low-frequency vibrations pass through walls into your bones. Outside, dust leaps in charged clusters, then rains in arcs like frozen confetti. Radio antennas sway on carbon fiber poles, their joints squeaking in vacuum. You key mic to mission control, but Farside has no real-time link. Instead, you listen to the quake fade, record its tones, and wonder which hidden fault side tonight. Astronauts on Artemis missions will wear haptic wristbands tuned to seismometer feeds. Gentle pulses might wake them if thresholds exceed nominal, much like earthquake alarms in Tokyo. Yet planners also see advantage. The regular, deep moonquake cycle can become a lunar metronome, a monthly rhythm reminding explorers to calibrate. Instruments rotate crops, reset circadian lights. Our bodies under 1/6 gravity may entrain to that 27-day heartbeat, weaving human routine into selenic pulses. Inhale. Imagine sinking dreams to tectonic lullabies. Exhale. Drift deeper into pillow as though lying on mere basalt cooled a billion years ago. Engineers propose deploying lunar vibraphones, strings embedded in regolith nodes that convert seismic energy into long, low musical tones. These could broadcast through habitat audio systems, turning raw quakes into ambient sleep soundscapes, helping crews relax while collecting science. Perhaps one night settlers will fall asleep to a chorus generated by a shallow moonquake 100 kilometers away, unaware that the note they hear is stone sliding against stone at snail crawl speed. Yet the deepest riddle remains. Why did one hemisphere end up heavier? Why did magma flood only one face? To solve that, we look to a shadow twin the moon may have swallowed. Keep breathing slow and steady. Let the moon's gentle quiver lull every muscle. Our final chapter drifts into the realm of cosmic siblings, an ancient twin lost in a slow motion. Collision? Glide onward to the moon's lost twin, two-moon theory. Feel curiosity lift you like tide under silver light, carrying you toward closing rest. The moon's lost twin, echoes of a forgotten sister. Imagine looking up at the night sky and seeing two moons, one bright and familiar, the other smaller, ghost gray, drifting ever closer until one silent night, the two become one. Draw a slow breath in through your nose, 4 gentle counts. Hold it, not tight, just aware, long enough to picture a newborn Earth basking beneath a pair of lunar companions. Exhale for 6 counts and watch the smaller orb. Call her Lilith, Selene, or simply the lost twin. Slide across the primary moon's far side like a quiet tide hidden forever from human eyes. This is the two-moon theory, a haunting idea proposed in 2011 that the moon we know today was forged not only from a collision with a Mars-sized Theia, but from a later, slower embrace with a second satellite, perhaps 50 miles across, formed in the same debris disk. Breathe in again. Computer models paint the scene. Both moons share orbit, yet their mutual gravities tug them into a horseshoe dance. Over tens of millions of years, tidal forces drain energy from the smaller body, causing its orbit to shrink. Eventually, at less than 2 miles per hour, slower than a Sunday bicycle ride, it drifts into contact with the larger moon's far side. No cataclysmic explosion, no molten spray, just a monumental thump, thick crust to thick crust, stacking layers of mountainous highlands onto one hemisphere. Exhale, releasing tension, like geologic pressure venting into space. Close your eyes. Feel the weight of that impact spread across your back, the way crustal waves radiated through lunar mantle. Geological clues support the idea. The far side's crust averages 37 miles thick, nearly double the near side's 18 miles. Its highlands tower a mile above the Maria Plains, studded with anorthosite peaks. The near side, by contrast, is marred by dark basalt seas, Mare Tranquillitatis, Imbrium Serenitatis, floods of lava that welled long after crust cooled. Why the stark difference? A half-moon's worth of material gently plastered onto one hemisphere could insulate and thicken the far side, redirecting interior heat toward the near side, where magma later bursts through. Inhale softly, envision. The South Pole Aitken Basin, 1,600 miles wide, excavated deep enough to expose mantle rock. Its floor shows minerals, orthopyroxene and olivine, rarely seen near the surface. Could that basin mark the splatter zone of the lost twin, its momentum punching shock waves around the globe? Or is it a separate scar carved by a later asteroid? No probe has yet sampled its hidden floor. The mystery lingers like a lullaby half-remembered. Now shift focus to creep, potassium, rare earth elements, phosphorus, radioactive heat producers concentrated on the near side. Seismic tomography suggests those pockets melted crust from below, flooding Maria. If the lost twin blanketed the far side crust in anorthosite armor, interior convection might have shunted creep toward the unburdened hemisphere. You can almost hear magma groan, seeking the path of least resistance. Exhale lightly, letting that imagined heat diffuse through blankets and fade. Recent data from NASA's Grail mission map gravity anomalies in tapestry detail. On the near side, mascons, buried, dense materials, pull probes into subtle dives. On the far side, gravity highs are broader, softer, smeared by the added crust of an extra shell. Visualize planets as pottery. If you press soft clay onto one side of a half-fired bowl, you thicken and unbalance it. The pot still spins, but wobble lines freeze into glaze. Our moon spins that pottery record across the cosmos each night. If the moon's face is a mask, maybe its backside is a hidden scar, an ancient seam where a vanished companion lies forever buried. Let your breathing fall into tidal cadence, in with rising seas, out with receding foam. Imagine two dawns on primordial Earth, twin crescents waxing and waning, their tug-o-war lifting tides thousands of feet. Such extremes might have mixed nutrient soup, concentrating chemistry cycles. Some evolutionary biologists speculate that wide tidal flats, filled then drained twice per double lunar night, could accelerate the polymerization of RNA. Does life on Earth owe its spark to a duet of moons, or was one enough? By the time the first stromatolites breathed oxygen, the smaller moon was gone, fused into far-side highlands. What remnants remain? If astronauts one day drill a mile beneath Humboldt crater's ejecta blanket, they may find regolith layers suddenly, enriched in magnetized iron, signature of a differentiated core splattered like jam against crust. Or they might uncover breccias older than any near-side rock, isotopes betraying a cooling history distinct from the Big Moon. Each sample will read like a diary entry in archaic script. The quiet crash that echoes still computer simulations show the lost twins' merger would produce no global magma ocean, only local melt zones. That explains why isotopes in Apollo rocks contain no trace of a later, moon-wide reset. Instead, the collision's energy becomes structural layering. Farside mountains grow. Crust thickens. Over billions of years, micrometeorites sand down dramatic relief into rolling highlands. Yet, orientation of remnant magnetic swirls, Reiner Gamma's curlicue in Genai's loops, matches fields that would swirl if a second moon's iron core smeared across mantle, then cooled. Inhale, letting eyelids flutter but remain closed. Above, your resting body, the real moon glides westward, locked to Earth's rotation by friction, older than Sahara sand. Each year it drifts outward 1.5 inches. Were the lost twin still aloft, resonance would differ, recession slower, days shorter. Our 24-hour rhythm, our society's time to sunrise and set, products of a single satellite's pacing. Once there might have been shift work under twin lights. Picture night fishermen hauling nets beneath two silver discs, one casting long, sharp shadows, the other pale and shy. Exhale and let those shadows lengthen across the margin of dreams. Testing the twin hypothesis, China's Chang'e 6 sample return mission aims at the South Pole Aitken Basin. If isotopic ratios show materials formed in cooler, far-side insulated mantle, models supporting a crustal plaster gain weight. The Artemis program plans radar soundings through thick highland crust. If reflections reveal buried layering inconsistent with global differentiation, more clues emerge. Each future drill core could chip away at silence, perhaps exposing breccia with exotic siderophile elements, nickel or chromium, that match no known near-side source. In this way, rocks become storytellers, pebbles become poets, and if we confirm a twin once danced above us, what other ghosts of early chaos haunt our quiet skies, waiting unblinking for curious dreamers to open their eyes? Let a final inhale gather every fragment of lunar lore, tidal quakes, phantom music, buried seas, hollow whispers, and a lost sister sleeping in mountain bones. Exhale, releasing them like meteoric dust, settling gently across your thoughts. You've journeyed through 10 chambers of lunar mystery, each a lullaby of stone and shadow. If these cosmic stories lulled your mind or sparked your curiosity, tap subscribe and ring the bell so our next midnight voyage finds you. In the comments, tell Dr. Weird where on Earth you're watching from and what time the moon rose in your sky tonight. Your answers stitch our global pillow fort of dreamers one tail closer to the stars. Now, close your eyes, let silver light fade behind lids, and drift into sleep, guided by silent tides and the faint eternal echo of a moon that may once have been two. Good night, explorers.